So friends, let us see this question. This question says the initial weight of a rocket. So we have a rocket. Initial weight of this rocket is W1. After engines are started, so this is the situation at t equals to 0. The fuel is expelled. The amount of fuel is proportional to time. When the fuel has been burned up at the point in time t, so after t equals to t, when the fuel is completely burned up, the engines are turned off, the weight of the rocket has decreased to wt. So at this time the weight of the rocket is wt. Which of the following equations applies for the rocket weight w at the point in time t in the interval 0 to t. So what should be the mathematical representation for the weight of this rocket in between t equals to 0 to t equals to t? Okay, let us see some keywords in this question. The fuel, okay, the amount of fuel is proportional to time. What does it mean? It means the fuel is proportional to time, right? So we can say this is a linear relationship. If we are saying that fuel is proportional to time, it means we want to say that fuel and time are linearly dependent. If we try to visualize the situation in graphical mode, so at t equals to 0, so total weight of the rocket was W1, right? And after time t, the capital T, the weight has been reduced to Wt. Let us suppose this is the Wt, and this going to vary linearly. It means this is going to decrease linearly. So this should be our graphical representation. This should be W1 and this should be the weight Wt. Now we have to find the expression, or we can say the equation of this straight line. What should be the, we can find y is equals to mx plus c. If we want to write this straight line equation in this form, in place of y I have weight w, so I should write w is equals to slope. We don't know the slope right now. In place of x we have the variable t, time, right? And this plus c, the y-intercept. If we see carefully in this graph, the y-intercept is w1, obviously. So c should be w1. How we can find the m, the slope or the gradient of this straight line? So we can find it very easily, y2 minus y1 upon x2 minus x1. So y2, suppose this is the first point, that is the 0 comma w1, right? This is the second point and it is t comma wt. So y2, that is the wt minus w1 upon x2, that is the t minus x1, that is the 0. So it should be wt minus w1 upon t, right? And see, wt is negative. Wt is not negative. Wt is basically lesser. It is less in magnitude with respect to w1. So ideally, this going to be a negative number. And obviously, the slope of this line you can see is a negative number. So either you can write in this way also. If you take negative outside, so you can write w1 minus wt upon t. Now this is better representation for your gradient. Now we have this m, we have this slope. So let us write the equation. W should be equals to, we can write w minus of w1 minus wt upon t into t plus this is w1. Let us try to find the best option for this situation. So please see the D. W is equals to W1 minus WT upon T into small t. So this is the best option to represent this situation. I hope you have understood this question. Thank you. Thanks for watching.